What did a Neanderthal voice sound like? It's a simple question, but the answer gets complicated fast. For a long time, we pictured them as brutes, hunched over, dragging their knuckles, making guttural grunts. Think of any cartoon caveman. That was our image of a Neanderthal. And their voice? It had to be a deep, booming, simplistic thing. A series of grunts and growls. More animal than human. But that picture is wrong. It's based on old science and even older prejudices. The first Neanderthal skeleton to be seriously studied was that of an old man from a place in France called La Chapelle aux Saints. He was arthritic, his spine was curved, his jaw was worn. The scientists who studied him, Marcel and Boulay, reconstructed him as a stooped, ape-like creature. This image stuck for decades. It colored everything we thought we knew about them, including how they communicated. And if you think a creature is stupid and ape-like, you assume its voice is. It's a natural leap. But science has moved on. We have more fossils now. We have better technology. We have a more open mind. The picture of the Neanderthal has been completely redrawn. They were not stooped ape men. They stood upright, just like us. They were incredibly strong, adapted to a harsh Ice Age world. Their brains were, on average, slightly larger than ours. They were also sophisticated. They made complex stone tools, a technique called the Mousterian industry. They hunted massive animals like mammoths and woolly rhinos, which required cooperation and planning. They controlled fire, they cared for their sick and elderly. We have fossil evidence of individuals who lived for years with debilitating injuries, meaning someone in their group was feeding them, protecting them. They buried their dead, sometimes with what looked like grave goods. They used pigments like ochre, maybe for body paint. They made simple jewelry from eagle talons and shells. Think about all that. Cooperation, planning, teaching, caring, ritual. Can you do all that with just grunts? It seems unlikely. All this complex behavior points to a complex mind, and a complex mind usually communicates in a complex way. It points to language. So, if they likely had language, what did it sound like? To answer that, we can't just guess. We have to look at the physical evidence. We have to rebuild the Neanderthal vocal tract piece by piece from the bones they left behind. The first place scientists looked was the larynx, the voice box. Your larynx sits in your throat. It contains your vocal cords. The position of your larynx is critical for speech. In adult modern humans, the larynx sits low in the throat. This creates a large resonant chamber above it, the pharynx. This space allows us to move our tongue back and forth, up and down, to create the wide range of vowel sounds we use. Think of the sounds of I and U. They are the cornerstones of speech, and they are formed by radically different tongue positions. For a long time, scientists believed Neanderthals couldn't do this. Back in the 1970s, a researcher named Philip Lieberman looked at the shape of a Neanderthal skull base. It seemed flatter than a modern human's. He argued that this meant their larynx was positioned high up in the throat, much like a chimpanzee or a human baby. A high larynx means a small pharynx, and a small pharynx means a very limited range of vowel sounds. Lieberman's model suggests that they couldn't produce those critical E and U sounds. Their speech, if they had it, would have been severely restricted, maybe sounding nasal and slurred to our ears. This idea dominated for years. It fit the old narrative of the brutish, less evolved Neanderthal. But there was a problem. The reconstruction was based on linking the shape of the skull base to the position of soft tissues like the larynx. This is a tricky indirect connection, and other researchers started to question it. They argued that the skull base wasn't a reliable guide. Then came a huge discovery in the 1980s. At a site in Israel called Kibara Cave, archaeologists found a stunningly well-preserved Neanderthal skeleton. And it included a bone that is almost never found fossilized, the hyoid bone. The hyoid is a small, U-shaped bone that floats in your neck. It's not connected to any other bone. It's held in place by muscles and ligaments. It's the anchor for your tongue and a critical support structure for your larynx. Your hyoid moves when you talk and when you swallow. It's absolutely essential for modern human speech. Before the Kibara discovery, no one had ever found a complete Neanderthal hyoid. And when they analyzed it, they were shocked. It was virtually identical to a modern human's. Not just in shape, but in its internal structure, which showed it was used in the same way. This was a bombshell. If their hyoid bone was the same as ours, it meant the whole foundation of their vocal anatomy was the same. It strongly suggested their larynx was positioned low, like ours. It meant they had the hardware to produce the same range of sounds that we do. The old theory of a high larynx and a limited vowel range was suddenly on very shaky ground. The hyoid bone was hard evidence. It suggested that Neanderthals had the potential for modern speech. But potential isn't proof. Having a piano in your house doesn't make you a pianist. Having the right anatomy is just the first step. There's another piece of the puzzle, and it's found in the ear. Speech isn't just about making sounds, it's about hearing them. Communication is a two-way street. Your ears need to be tuned to the frequencies of the sounds you're trying to understand. If you can't hear the subtle differences between sounds, then complex language is useless. So, scientists decided to investigate Neanderthal hearing. They couldn't listen through their ears, of course, but they could use high-resolution CT scans of Neanderthal skulls to create detailed 3D models of their ear structures. They looked at the outer ear canal, the eardrum, and the tiny bones of the middle ear, the hammer, anvil, and stirrup. These are the smallest bones in the body, and they transmit vibrations from the eardrum to the inner ear. By modeling how these structures work together, the scientists could figure out the optimal hearing range for a Neanderthal. They could determine the bandwidth of their hearing, the range of frequencies where they heard best. A wider bandwidth allows you to process more information, to distinguish between a greater number of different sounds, which is a key feature of complex spoken language. The results were another major revelation. The study showed that Neanderthal hearing was optimized for frequencies between 3 and 5 kilohertz. This is exactly where most of the acoustic information in modern human speech is concentrated. Their hearing bandwidth was wider than that of their ancestors, and it was squarely in the modern human range. Why would evolution shape their ears to be perfectly tuned to hear human-like speech if they couldn't produce it? It wouldn't make sense. It's like building a high-end radio receiver that's tuned to a station that doesn't exist. This evidence from the ear strongly complements the evidence from the hyoid bone. It shows they had both the production and perception systems needed for complex vocal communication. So the bones of the throat and the ear tell a consistent story. But what about the power source? The lungs and the control system? The brain. Neanderthals were built differently from us. They were shorter on average, but much more robust. They had massive barrel-shaped chests. This meant they had a huge lung capacity, much larger than ours. This was likely an adaptation to a cold, dry climate and a very strenuous lifestyle. But it would have had a side effect on their voice. To speak, you need a steady, controlled stream of air from your lungs. The larger lung capacity of a Neanderthal would have given them an incredible power source for their voice. They could have spoken for longer periods without taking a breath, and they could have been very, very loud if they wanted to be. Now, for the brain. Language isn't just in the throat, it's in the head. In modern humans, two key areas for language are Broca's area involved in producing speech and Wernicke's area involved in understanding speech. Well, we can't look at a fossil Neanderthal brain, but we can look at the inside of their skulls. The brain leaves an impression on the bone as it grows. These impressions, called endocasts, can give us a rough idea of the shape and organization of the brain's surface. Neanderthal endocasts showed that their brains were organized much like ours. Their frontal lobes, where Broca's area is located, were well developed. While endocasts can't prove they had language, they show no neurological barrier to it. The basic brain structure was there. And then there's genetics. In recent years, we've managed to sequence the Neanderthal genome. Scientists looked for a gene called FOXP2. In humans, this gene is crucial for the development of speech and language. People with a mutated version of the gene have severe speech impediments. When scientists looked at the Neanderthal genome, they found that Neanderthals had the exact same version of the FOXP2 gene as we do. This doesn't mean they had language, the gene's role is complex, but it does mean a key genetic barrier that could have prevented language simply wasn't there. So, let's put all this evidence together and try to build a Neanderthal voice. We know their vocal anatomy was very similar to ours. The hyoid bone tells us that. We know their ears were tuned to hear sounds in the same range as our speech. We know they had the brain structures and the key genes associated with language. What would this actually sound like? First, let's talk about pitch. The classic caveman voice is a deep, low-pitched rumble. But the physics of the voice suggests the opposite might be true for Neanderthals. The pitch of a voice is determined largely by the length of the vocal cords and the size of the resonating chambers in the throat and mouth. Neanderthal necks were shorter and thicker than ours. Their face and skull shape suggest a vocal tract that was shorter but wider from front to back. Think of a musical instrument. A smaller instrument, like a violin, produces a higher pitched sound than a larger one, like a cello. In the same way, a shorter vocal tract would tend to produce a higher pitched voice. So, contrary to the stereotype, a Neanderthal's voice was likely higher in pitch than the average modern humans, especially a male's. It wouldn't have been squeaky, but it wouldn't have been the deep bass, we imagine. Second, power. Their huge barrel-shaped chests and massive lung capacity would have given their voices incredible power. They could have projected their voice over long distances without shouting. Their speech could have been loud, forceful, and sustained. Imagine a voice that was higher pitched than you expect, but with the volume turned way up. The third, timbre or quality. This is the hardest part to reconstruct. Some researchers have pointed to their enormous nasal cavity. The inside of a Neanderthal's nose was huge compared to ours. This large space could have given their voice a more nasal quality. This doesn't mean they sounded like they always had a cold, it just means the resonance might have been different, with more sound passing through the nasal passages. It's a subtle difference in tone that would have made them sound distinctly non-modern. So, what's the final picture? Let's try to hear it. Don't imagine a grunting, roaring brute. Instead, imagine a voice that is surprisingly human. It can produce all the same vowels and consonants that we can. It's capable of forming complex words and sentences, but it sounds different. The pitch is a bit higher than you'd expect from such a stocky, powerful body. The voice itself is incredibly strong, capable of great volume without strain. And there's a subtle nasal resonance to it, a different quality of sound that marks it as something other than modern human. It would be a voice fully capable of nuance. It could be used to teach a child how to knap a flint blade. It could be used to coordinate a hunt for a woolly rhino with calls and instructions passed between hunters. It could be used to tell a story around a fire, it could be used to comfort a sick family member, or to mourn the dead. This brings us to the final, crucial distinction. We've been talking about speech, which is the physical act of making sounds. But what about language? Language is the system behind the sounds, the grammar, the syntax, the shared meaning. It's the ability to talk about things that aren't right in front of you, the past, the future, abstract ideas, social rules. Did Neanderthals have that? The archaeological evidence strongly suggests they did. You don't bury your dead with ceremony if you can't think and communicate symbolically. You don't create ornaments from eagle talons if you don't have a concept of identity or beauty. You don't sustain a complex tool-making tradition for over 100,000 years without a sophisticated means of teaching it to the next generation. All of these things point to symbolic thought, which is the bedrock of language. Their language may not have been identical to ours. It might have had a different structure, a smaller vocabulary for certain things, and a richer one for others. Perhaps their grammar was simpler, or perhaps it was complex in a way we can't even imagine. We will never know, for sure. The sounds they made vanished into the Ice Age era tens of thousands of years ago. But the silence they left behind is not empty. It's filled with clues, the shape of a tiny bone in the neck, the curve of an ear canal, the impression of a brain on a skull, the pattern of a well-made tool. These clues all point in one direction. They spoke, and when they spoke, they didn't grunt. They used a voice that was powerful, surprisingly high-pitched, and fully human in its potential for expression. Hearing that voice, if we could, would be one of the most profound experiences imaginable. It would be the sound of a different kind of humanity, a cousin we long misunderstood. It would erase the last traces of the brutish caveman caricature and replace it with the voice of a person looking out onto a harsh and beautiful world and talking about it with their family.